Internet of Things, and Agriculture. Hello, I am Maria and here is Haralambos. We are studying Applied Informatics at University of Macedonia, and we are going to show you our application Planty, a smart IoT plant. We will explain what does the Internet of Things mean, worldwide known as IoT. Internet of Things is a network of physical objects that are connected to the Internet, allowing them to send, receive and exchange data. How does it work? Smartphones, tablets and other smart devices can control all types of things. Cloud services provide the repository and access control between the things and its controller. Most things connect to the Internet except for power grids or classified government systems. This may be a controller area network, in connected cars, a local network in homes, etc. Things can be remotely controlled or viewed and they can send data for analysis.
What was the main reason to work on IoT?
The IoT is the emerging disruptive technology for the 21st century.
The number of Internet devices in 1984 was only 1,000. After 31 years, the number of Internet devices reached 15 billion. Nowadays, there are almost as many mobile devices as there are humans on planet. 7 billion devices. For 2020 the number of IoT devices is forecast to grow to almost 31 billion worldwide.
Nowadays, IoT is in every sector of our life. The main sectors of IoT are 8. A smart city has citizens that make optimal use of all the interconnected information available today to increase efficiencies, reduce costs, and enhance quality of life. Smart transportation systems will optimize the movement of people and goods, improving economics, public safety, and the environment. In smart education, learners utilize smart devices to access digital resources through wireless network and to immerse in both personalized and seamless learning. Smart energy defined as a flexible and intelligent system of integrated energy grids which ensures cost-effective and sustainable energy supply, storage, and consumption. Smart manufacturing enables all information about the process to be available, when and where it is needed across entire manufacturing supply chains and product life cycles. Smart healthcare is the use of information and IoT for health. Examples include treating patients, conducting research, educating the health workforce and tracking diseases. A smart home, or building, is a place where Internet-enabled appliances and devices can be automatically controlled remotely, using a networked device. Smart agriculture is an approach to farm management that uses IoT to enhance agricultural production and productivity as a way to produce more and better, being environmentally friendly by promoting sustainable patterns of production. There is large potential for IoT in developing agricultural sector. Here are some domains that already IT services exist. The value of smart agriculture and its positive impact on the community and on natural environment has prompted us to focus on this domain of IoT. As a small team we tried to make something simply but worthy. We tried to differentiate our project. Therefore we can show you our project Planty. Planty is a smart plant that collects data from environment and then moves to an area with perfect conditions for it. We do not regulate environmental conditions. The plant is finding the best environment. We have created an application to control the conditions through sensors and its movement. Let's analyze the architecture of this composite system. Everything is connected with Raspberry Pi 3 Model B. We have the breadboard, T-cobbler, 40-pin ribbon cable, other cables, the resistors, motors, sensors and the camera. Raspberry Pi 3 Model B is a complete Linux computer and can provide all the abilities that implies at a low power consumption, and has onboard Wi-Fi, Bluetooth and USB. We use SI 1145 sensor to get dynamic data for IoT spectrum, visible light and UV spectrum. Here is another sensor, DHT11, which gets data of the temperature and the humidity of the air. Another important sensor is SEN 13322, that recognize if the soil is moisture or not. There are two distance sensors HCSR04 to avoid crash with other things or wall. There is one front and one in the back of the structure. Except of sensors, we use 2 DC motors with each one connected to a motor driver DRV8801. These are responsible for the move of the structure to any direction. Last but not least, we have connected Hercules Classic Silver webcam with USB that is responsible for the smooth live video in the application. A power bank provides power to our robot. Let us show you now how is possible to build a robot like this. We are using a Python web framework called Flask to turn the Raspberry Pi into a dynamic web server. The web page contains a Python script where the functions of the Planty exist. There are 6 endpoints, each for a different move of the wheels. We tried to have a realistic move of the robot, therefore it can go everywhere. A JSON archive is being created in another endpoint. This archive contains all the data that sensors are sending. The communication between the distributed systems is succeeded with HTTP protocol, through the port 5000 of the router, that we have set especially for this reason. The Raspberry Pi, and the application Planty, communicate with GET requests methods. A camera is connected with USB to Raspberry. A software called Motion gets the video from the camera. When we start the application, automatically a request is going to Raspberry. Through the port 8081 of router that has been set for this reason, the data are transferred and we have the live video. First we will show some important points on the Java code of the Android application and then the graphical user interface of it. In the beginning you can see all the functions that we used for our robot. All the data from the sensors that included in the JSON archive are presented here. Here is the video frame where we can see the environment in front of Planty robot. When we click the event button Get Data, a message for the moisture of the soil appear and down of it there are all the information from the sensors on the screen. Under the video frame, there are 6 different buttons each for another move of the right or left wheel. Here are the functions for the 6 motion buttons. 2 wheels back, 2 wheels straight ahead. Only the right wheel straight, only the left wheel straight. The same with back motion. Among of these buttons there are the data for the distance in centimeters between the robot and other things or wall. In conclusion, our project has an affordable cost even the abundant of the sensors, and differentiated from the others because of the remote control and the variety of moves. As for future developments we are thinking of using more sensors, therefore we will have a better observation of plant. Also a solar power bank will solve the problem of power. Last but not least, we should do some improvements on the interface of the application to be more user-friendly. Taking into account the international literature, the need of environmentally friendly infrastructures, we could admit that the key for the new age of innovation is IoT in agriculture. Despite the fact that we are just students, our project is innovative and we hope that it could be the beginning for something bigger in the agriculture sector.
We would like to thank you for your attention and your interest on our project.